Hi Manchester, it's my first time in UK, so sorry a little bit about my Ukrainian English, so I hope you will get used to it. So my talk of today is going beyond Magento speed limits, and the small remark over there in the bottom of the screen, as you see, it's without HHVM and Varnish. This is something I really encourage people to do, like first to take a look at the code and where it can be improved. So you might wonder, right, who is that guy on stage? Do you know? Okay, a small suggestion for you. So this is a guy who you can blame for all the terrible Magento 1.x architectural issues you can find over there. I was one of Magento core developers who actually started the project, and I was one of the 5 core team members who actually created the base that you are currently using and that you are currently hate, right? So, jokes apart, why actually without HHVM and Varnish? So, first of all, because HHVM, it's actually compiles your code into opcode, or actually a compiled C code for HHVM, or if it's PHP opcode cache, it's opcache. And Varnish actually caches its output. They both do not solve a problem. They do not solve a source of the issue. And the source of your issue is always your code, right? The code that smells, many people were presenting today issues in the code, examples, and so on. I saw so many familiar stuff that I deal day to day when I consult my customers and trying to do some performance analysis for them. So, most of the Magento core developers also treat Magento core as the holy grail that must never be touched. And we saw so nice pictures already today with bands that tell, okay, do not touch Magento core, never, right? So this thing should be touched. And you should touch core, of course not hacking the core files itself or putting them in local or other stuff. Do a proper touch of Magento core, right? So touch it gently. So it should be touched for a good reason, right? If you have a performance problem, it should be touched for sure. So just take a look at this simple example in Magento. Probably every one of you dealing from day to day with Magento layout, right? So let's say Magento caches layout for every request, right? And we receive a cached XML on every next load time of the page. So we are happy with it, right? It's quite fast, we receive a feedback, we get blocks rendered, we have the structure created, but there is a big problem around that because almost every page in Magento has a cache footprint for layout. So it's kind of small full page cache, but for layout. Because in Magento, as you know, all the layout itself is a combination of handles. And every category and every product have own layout handle, prefixed with product and suffixed with product ID, and category suffixed with category ID, right? So that's a little bit of a problem when you are short on resources on your server because your Redis cache is not infinite, right? So what if this thing can be actually structured differently, and if we could actually pre-assemble parts and make it more efficient from point of view of resources, right, and from point of view of performance as well. So if we take a look at that thing, I touched that Magento core part, but the most important thing that I did, I covered it with unit tests. And I made sure that everything that I do for performance in Magento core, I covered with unit tests. I make sure that I don't break anything, and I make sure that when you apply it on your website, it just works. So, what I did? First of all, I separated handles processing from rendering of Magento. So I have now all the layout handles that you have in every XML file being compiled into PHP files. Then I also process those XMLs with a separated process itself, so you can actually pre-cache your layout changes as well. You can also create your own layout node parsers, so you can generate different PHP code based on some kind of shortcuts in your layout file, so you're not anymore limited by standard Magenta core layout. So let's see how it compares in numbers. So I did some benchmarking. I use Gatling as my load testing tool. I use Hypernode Vagrant Box. Hypernode, it's a project of one of the Dutch companies called Byte Internet. They are doing some nice Magenta hosting. I use Magenta 1.9.1.1 as my base version. I use official Magento sample data for this test. I use Redis cache as a backend, so everyone in the same conditions. So Magento layout cache is retrieved as fast as I would retrieve some kind of my flags from cache as well. And I do 3 runs, each of 60 seconds, and each first run is a warm-up. And during the warm-up, I reset MySQL cache, I reset Redis cache, I reset everything. So we make sure that we have the full information what happens on the first run for Magento, and the full information what happens if we have a layout compiler enabled. So let's see at Magento, right? If you take a look here, we have quite interesting response time distribution. It's all category pages, home page, and product pages being tested. And we have a mean time of 600 milliseconds, with most of the requests being completed around 1 second, right? Not a bad result for Magento, but we should consider that it's just a sample data with not that much products and categories. And the thing that I don't like in Magento is a deviation time. It means like every request can be different by 300 milliseconds, so it's not that reliable in the end. And the first run for my module, also not that good result itself, but a little bit better than Magento, right? So it returns a result within 488 milliseconds. So it's already something like 100 milliseconds more efficient on the first run. And deviation is not that good as well, a little bit lower, something like by 50 milliseconds. But we can live with it. And if you take a look here, most of the requests tend to be also within 1 second, but if you take a look at the percentage itself, this is most of the requests coming in. And this small thing, it's actually when I compile all the layout XML structures into PHP code on the first call. Here we have the second run of Magento. It shows a little bit better as a result, like we have 566 milliseconds, and deviation time is still not that good, still 300 milliseconds. It's not that reliable still. And layout compiler on the second run shows much more better result because we don't have anymore that phase when we need to transform XML to PHP. And also we have some special flags being cached as well, so we don't do file and time for every layout file in order to check if it's changed comparing to the current PHP compile file version. So if you take a look here, we have a mean time of 400 milliseconds. The deviation is quite not bad, right? Below 200 milliseconds. And we can see that all the requests tend to be within 800 milliseconds. So we have quite good achievement just by changing the way how Magento layout is composed, how it's used, and how it's produced. So there is nothing different from the way how blocks are created or how pages render it. The only difference here is the way how we load the layout files. So I decided to experiment a little bit more with Magento core code. Unfortunately, I didn't have that much opportunity when I was on Magento core team. So I did another thing, and I took a look at Magento category pages, and I realized, okay, there's a little bit of a problem because every filter has a cache footprint as well, additionally to our layout cache footprint, right? So every combination of filters you have on Magento category page has a cache entry. And it also eats up your Redis memory cache that you can spare for a better reason, right? You still can use Redis cache for something more important for you. So another thing that there is a problem that for every filter there is loading process of options. And every filter actually loads all options for table source attribute, right? The one that is stored in a single table, but we still have, if we have 10 layered navigation filters, it means that 10 times we will ask that table to retrieve this data for this attribute. And if your customer is a big fashion retailer, right, they probably have thousands of different attribute values for those source table, right? And in the end, all this data gets loaded. You eat up your memory on a server. And also, behind the scenes, Magento also does a for each on all these options, and that's terribly slow. So as more data you have, Magento layered navigation actually produces not that good results. And any one of you experienced some terrible SQL queries that are executed on layered navigation pages? Okay, so not that much people here in the room actually take a look at slow log, right, of MySQL. And everything is so tightly coupled in Magento 1.x in layered navigation, like you cannot separate attribute from the search facet. It's still like something that is so tightly coupled, and if you try to separate it in a standard Magento layered navigation, you will fail because, yeah, it's never going to happen. So I decided to experiment, and I thought, okay, what if we separate facets from attributes and make them totally different data itself that are going to be used by our search and category pages? I also decided that why not to load all options at once and only the ones that we actually have for our current subset of products. We don't need thousands of options and to walk through them through for each. We just can retrieve needed options at the needed time. Also, product collection should not be used for retrieving of layered navigation options, because as soon as we try to use product collection select joins, we may run into trouble if third-party extension or something else actually joins some additional data to this collection. And if we have group bys, yeah, our MySQL server will not live without some nice optimization afterwards. So I decided to experiment, but I cheated a little bit, and I don't use MySQL for it. I'm using Sphinx as a storage and as a provider for our catalog and for search results as well. So a lot of you might ask, why Sphinx? Why not Elasticsearch? Why not Solr? That is very simple. First of all, I don't need to install any Java on the server. You know, like most of the people need to install Java in order to run Solr or Lucene-based solution, other Lucene-based solutions. So Java is not the case because not all the hosting providers can give you possibility to install Java and run this expensive software. Another nice thing in Sphinx is that it supports SphinxQL. It's a kind of query language for Sphinx that is communicated through MySQL client protocol, so you don't need to install any additional PHP extension in order to use Sphinx. And another thing, like Sphinx is used by Airbnb and Craigslist in order to provide you the best search results available. And of course, Sphinx can be executed as your web app user. You don't need to have sudo rights in order to run Sphinx daemon. So let's see how using Sphinx can change the way how Magento behaves. So this is still standard Magento sample data, and this is average catalog pages on Magento. As you see, the result is 400 milliseconds, deviation is 200 milliseconds. This is the result with layout compiler enabled, so we already had some performance improvement for Magento. Then I decided to serve some catalog pages from Sphinx, and the result was quite interesting. Like the mean time was 232 milliseconds, and the deviation time dropped to 86 milliseconds. And as you see, most of the requests are served within 400 milliseconds. So quite nice solution for a small database. And the category pages for Magento, as a comparison, theirs was all catalog pages. Category pages of Magento are executed within 463 milliseconds, and deviation is 115. Maybe too much benchmark results, but you will have to wait for something a little bit later. So here we have also something interesting, like Sphinx returning still consistent result for all category pages. It's 223 milliseconds, and 51 milliseconds is the deviation time for category pages. But that's actually not a real-life situation, right? Not every shop has just sample data of Magento, so not that small amount of products that Magento has. So I decided to duplicate sample data, and I created such a database with 3 store views, 22,000 SKUs, about 1,000 items per category visible on catalog. And the results I get has been tested with 150 concurrent visitors. With such a behavior, like I visit first the home page, I visit the category page with applied filter, then I hit the search page to retrieve some search results. And Magento first run was still quite okay, like it's 529 milliseconds with a deviation time of 222 milliseconds. So not that bad for 22,000 SKUs. But this is only when you have flat version of catalog enabled. And then I did the same task for Sphinx, and here I was amazed. Because it doesn't matter the size of the catalog itself I was using, it still was returning a result within 238 milliseconds. So I still can rely on Sphinx for bigger catalogs and for bigger load on my server. And the deviation time went to 47 milliseconds. So still the same. So I still can rely, and as you see, there's not that much deviation from the request. So it looks more discrete. If we take a look at Magento first run with the filter applied, we see still like it's 524 milliseconds and 290 milliseconds. And with Sphinx, yeah, it still doesn't go below 300 milliseconds. Here's also a search page. So 461 milliseconds, and deviation time is 211 milliseconds. It's very strange, like deviation time is stable in Magento, like all the time 200 milliseconds. So you can expect that next request you fire to Magento, it can be different by 200 milliseconds, less or more. Now, the search page with Sphinx, 200 milliseconds and 49 milliseconds deviation time. Quite not bad. So, the second run, Magento shows a little bit better because MySQL cache is pre-warmed. Then we have Sphinx run. Yeah, it still shows consistent result. And then we have filtered pages. Magento shows a little bit better result because of MySQL cache enabled. And filtered category pages in Sphinx. Search page, 441 milliseconds in standard Magento, a little bit better. And now search page with Sphinx, also 200 milliseconds. Quite stable. But Magento actually still has plenty of bottlenecks to solve. And some of them, right? Let's say we have indexers in Magento. Who ever struggled reindexing full data on live environment and putting the website down? So everyone got this nasty experience, right? So what is the problem over there? Actually, downtime increases with the size of the catalog you have during full data reindex. Also, the indexation speed is not the best one you can achieve by using a little bit different approach, right? So, how to solve these issues? What can be done? We can actually copy the table, fill in with the new data, rename table on the full reindex, and then we don't have downtime because we still serve data on the front end from the old index table, and then we just switch the tables and everything works fine on the front end. We don't have downtime, we don't have angry customers who cannot purchase products. This simple change can bring your customer experience on your merchant websites to a different level, because the update of the data goes through. You don't need to bring down all your website to reindex all the data, and you still can sell products. Also, it's always worth to write your own indexes for your own subset of the data. It's worth to take a look at the data that customer needs, to think about which indexes you don't need. For instance, you don't need, for instance, bundle product price indexers if you don't use bundle products. Or, for instance, if you have a policy for configurable products that only simple product prices are used, you shouldn't use Magento configurable product price indexer, because you need to write your own. So don't hesitate to touch that part of the code in core. But always do it in a proper way, right? Gentle. Also, there is another issue. A previous speaker was telling today about the configuration issues in Magento, right? With the concurrency and locking. But there is a big problem with the configuration merge process itself, because the more services you have, the less you can scale with Magento, because your configuration file is increasing a lot. And I had a customer who had 90 store views. 90 store views. It means that on every request, we got at least 150 megabytes only dedicated to the cache of the configuration being loaded. And we couldn't scale PHP processes enough unless we fix this issue with this configuration stuff. And actually, not every data in configuration file is needed for every your request. So you can optimize that part as well. So what can be done? First of all, load configuration only for a current store view. You can achieve a small trick by using a cache processor, the one that is used by full-page cache in enterprise. You can create your own cache processor to replace some system objects of Magento without actually rewriting the core files. So some kind of smart memory trick. And by doing this, you can replace a configuration model that will load data only for your current store view and implement a lazy loading of the additional store views when it's requested. So you don't load all the store views configuration values at once. You don't waste your memory. You spend less money on the hardware, so you can serve more customers with a smaller server. Another thing, you need to share only required data in configuration for another store view. For instance, you want still to be able to switch a URL when you render a drop-down of the store views available right on a website. So for this thing, you can actually merge only particular subset of the data into big XML structure, and for the rest of the things, you can just invoke lazy loading. Another thing, it's a product view, and this is the most terrible part in Magento, because actually, you remember the thing with alert navigation options, right? So can you imagine when you render this additional information block in Magento, like Magento actually walks through the array of all the available options in attribute to find an attribute option by ID, and then outputs a label of it in this table. And if you have 10 or 20 attributes with at least 100 options in every of them, it means you spend a lot of CPU cycles just for nothing. Redundant EAV data is loaded. Not every EAV data is needed for your product on a product view, because most of the EAV data is used, for instance, for recurrent profiles that is not needed for you. The data like, for instance, shipping method, availability that some extension add to a product are not needed for product view. A lot of attributes that you can actually to pinpoint and use only the ones that you need. And flat collections are not used for some of the product types. That is quite a common issue. So what can be done with it, right? First of all, you can load only options you need for attributes. So you can actually, after load of the product, you can preload options of our attributes itself to not load them from the database separately for every attribute. You can load partial product model. If you ever seen in Magento, there's actually a possibility to load only some subset of attributes you need by invoking partial load behavior of a product. Just take a look at it and try it out on your projects. I think you will notice a difference in performance because some of the attributes are executing some heavy after load operations. And if you don't need those attributes to appear over there, use always a partial load. Sorry. And another thing, of course, use flat collections for relations, group products, and configurable products. There is some tricks already available from my previous presentation in other European conferences. You can look it up on my Prezi account later on after a conference, or just Google it. So we have the last one and the most important one, it's checkout, right? Slow checkout means more frustrated customers to proceed to the final success page. So what we have from the common bottlenecks over there is actually inefficient price retrieval from a database. If you take a look at Profiler, as many products you add, as many database queries you have to retrieve tier prices or to retrieve special prices from catalog pricing, catalog rule price index table. Also, you have some payment methods that actually doing API calls where they are not needed. And shipping methods do the same thing as well. So to pinpoint these problems, first of all, you need to use some kind of collection load events. If you are working with checkout, you probably know that all the products are loaded on some special event into the quote items, right? So you can take this event and you can preload the data that later on will be just reused by Magento without lazy loading later on. So you can preload all the tier prices, you can preload all the catalog rule index and so on. For PSP and shipping provider code, you actually need to take that extension and make sure that API calls are cached that are not depending on the customer data. So some things that do not depend on the customer data, like for instance, this payment method is enabled for this country, or this shipping method delivers to this city, should be cached. It doesn't depend on the customer data, it depends on the location or your configuration in the admin panel. So that's all, but there's much more issues in Magento core, but I cannot cover them in this time frame for this presentation, unfortunately. How about Magento 2? You know, like, I work a lot on different open source performance projects, and some of you maybe know me from my ecomdev PHP unit extension, but there is some roadmap of my next extensions that are going to be free and easy to use by you in Magento 2 as well. So I'm going to release a layout compiler in the first quarter of 2016. I'm going to release an indexing framework for Magento 1 and Magento 2. So you will have this kind of smart trick with table replacement. I also will release a alert navigation framework. So the implementations that will be kind of PHP library, and you will be able to use it in Magento 1, in Magento 2, or any other e-commerce platform available in the market. So here it is, our layout compiler module, the Vagrant box that I was using for tests, and load test results. So take a note of it. As soon as you are done, the final thing, Sphinx, unfortunately, it's not open source, so it's kind of things that I provide for my customers. So if you like, I can provide you a quote later on. Just email me. And here's a place for some questions. So you can also ping me on Twitter or send me an email later on. But for people who are asking a nice question here in this room, I have some nice Dutch presents. So raise your hand and tell me some questions.
Questions?
As we saw, you are quite good in statistics. Can you say something about Magento 2 statistic information about sales?
Sorry, do you mean the performance?
No, not performance, but performance of sales of business with Magenta. Like a statistic of sales of products and incomes from these products and so on.
You mean like reports?
Yes.
In Magento 2?
Yep.
I don't think that it's time actually to take a look at Magento 2 performance in general at the moment, because it's not yet released and generally available. So it makes sense to optimize a product when you have some kind of stable code base, which one you can take a look, profile, and pinpoint the issues with it and just fix an issue in the end. But as for reports concerning sales of Magento 2, yeah, I don't think that there's actually only one Magento 2 store as far as I know, and probably Ben can tell me for sure what is the name of the store, but I know there's some kind of one Magento 2 store is going live there, but I don't know statistics of it because I'm not involved in it. Sorry.
Any more questions?
But you have some strawberry waffles from the Netherlands.
Where are we?
Hi. When renaming your tables after you've re-indexed, don't you find there is a small lock time and wait time where your website will be down or will have to go down?
I don't talk about renaming tables on my SQL side. I'm talking about renaming tables on XML structure.
Ah, okay. That makes sense. Right. Okay, cool.
Nice question. One more strawberry waffles to go.
For your Sphinx integration, roughly, do you actually have to do the local core override, or can you actually put it in? Are you able to actually put it into an isolated module and just use the rewrites and the layer text? Not the layer XML, but the config XML.
Okay, the question was, do I actually use a local override or do I use rewrite in order to replace the catalog retrieval from Sphinx, right? The answer is none of them. I actually use layout XML in order to replace the layered navigation. That's all. But nice question. The last strawberry waffles are gone. If you have a question, you don't receive anything. But you still can ask.
No more?
Okay, thank you very much, guys.